G'day guys, it's been a while since I made a video, but I just thought I'd go over compound interest in a little bit more detail than I did in the first video that I made for it, particularly in regards to how the number of times it is calculated in a space of a year affects the equation. Where simple interest, it doesn't matter how many times it's calculated in the year, the equation basically stays the same because you're just using the initial principle. Compound interest, it changes the equation a little bit more in regards to how it works, because compounding the interest, or compound, when it's calculated via a compound, it means that the principal for the equation is the total at the end of the last interest calculation. So hopefully this will help make sense of that a little bit more. Do please forgive the hair and the general scragginess. Isolation has been quite entertaining for me. Alrighty, so let's get started with a bit of an example that'll help clear things up, I'm hoping, a little bit more. So if we started off with, say, $2,000, and this was gaining an interest of 10% per annum, and we had it in there for 2 years. So 2 years and 10% per annum. So if we had this particular situation, when we used our simple interest equation, well, it'd be very easy. The interest earned on the account would be, P times R times T divided by 100, and it would equal, $400 at the end, and we'd have a total of $400 interest that we have earned. Now, compound interest works a little bit differently, because instead of using just that principal amount to calculate for each year, so in the first year you've earned $200 interest, in the second year you've earned $200 interest, and then for subsequent years after, it's just $200 interest, $200 interest, $200 interest every single time. For compound, this is the simple interest equation. For compound interest, it works with the total after the first year. So, it'd be $2,000 times your 10%. Of course, my tablet would have a little bit of lag just then. And times our first year divided by 100. So that gets you your first amount of interest earned. So that's the $200 after your first year into the account. Well, this $200 gets added to your initial $2,000 to make the new principal for the next year. Okay? So for the second year, it's $2,200 times 10% times that year that's going to be in the account for, divided by 100. And that will get you your brand new interest amount in the account, which is going to be, $220. Sorry, I had a bit of a brain lag there. And so then this will then get added to your principal for that year, and then this becomes the principal for the following year, and then the same pattern continues. And so that's how compound interest differs from simple interest. But which is great if you're investing money. This is a great way to double, triple your money in a very short amount of time, compared to your simple interest, which is just giving you a stock standard $200 every single year. But what happens if in fact that changes? So if we stop thinking in single years, and we start thinking in it being calculated across a different time frame, then the equation can change again. And so for this, we're going to use this example. So we've got $5,000 in an interest, a loan of $5,000 with an interest rate of 7.3% per annum for 3 years. So if we go ahead and do this with our yearly equation, it's going to be $5,000. Sorry, I should in fact start that again by saying that our equation for compound interest as a whole, to stop having to do each single year, so simple interest, and then go again, simple interest, go again, it's going to be the amount in the account is equal to the principal multiplied by 1 plus the rate divided by 100. You can do this prior to plugging it into the equation times the time frame that it's in there for. Okay, or the times that it is calculated. I'm sorry, not the time frame it's in the account for, but by the times the interest is calculated. So if it is calculated yearly, our equation is going to be 5,000 times 1.073. Okay, because 7.3% per annum divided by 100 is equal to 0.073. And the amount of times it is calculated is per annum yearly, so that's over 3 years, which means that the total compound interest, or the total in the account at the end of that time, will be $6,176.88. Sorry, you would have seen me pause before. That was just because I was just confirming this calculation was done correctly. Cool. So, that's fine and dandy, and it makes complete sense. You know, we've done this calculation if we did it yearly. But what happens when it's actually calculated bi-yearly? Bi means 2. It's not every 2 years. That would be biannually. Bi-yearly means twice a year. Okay, so it's calculated every 6 months or every half a year. So this changes the equation a little bit. No longer are we working with just our usual rate and our usual times calculated. Because the rate is per annum, per year, we have to manipulate the rate to suit the amount of times that it's being calculated for. So our new equation will be A is equal to the principal, so far the same, times 1, plus the rate divided by n times 100. N is going to be our number of calculation times, or number of times that is being calculated. Like I said, bi-yearly means it's happening twice a year, so n in this instance is going to become 2. Then the times calculated gets manipulated as well. So it's the power of times calculated, or time in years, times n. I'll show you how this works so that it makes a little bit more sense as well. I'm not going to leave everyone in the dark for this one. So bi-yearly, we're going to have our principal of $5,000. I have no idea why I went to go write that again, so I'll just make that an A, is equal to $5,000 times 1 plus 7.3, that hasn't changed, divided by 2 times 100. My apologies for writing on a slant as well, no idea why that's happening. So, now that we've got this 2 times 100, obviously we could simplify that to 200, because we know that 2 times 100 is going to be 200, so it's going to be 7.3 divided by 200 in the end here. And then we have our 3 years, but again, it's happening twice a year, so that's going to be 3 times 2 in that scenario, in this scenario here. All right, so this, again, simplified again, we'll go 5,000. I'll try my best to write them straight on this time, times 1 point and 7.3 divided by 200 is going to be 0.0365. So it's 1.0 365 to the power of 3 times 2, which is 6. So we are going to end up with a total in the total loan amount at the end of this time frame of $6,199.92. So it's interesting, right? We have an increase in the amount of interest that has been added to the account. This total here, which is just a straight up compounded every single year for 3 years, is giving us a good, $23 odd less in the account. Than if we compounded it every half a year. And this is because what happens is that remember that total at the end of every 6 months becomes the new principal for the following 6 months, and then again for the new principal for the following 6 months. So you're actually getting more money added to the total after every 6 months than you would get after every year. And so sometimes, you'll find that, calculating interest getting calculated every half a year on an account where you've got a loan sitting in there isn't necessarily the best thing to have happen. So the last example is fortnightly. A lot of students come up across this, or a lot of people come up across this kind of scenario here for fortnightly calculations, and they get a little bit lost. And that is because, for two reasons. People don't actually understand that there's 26 fortnights in a year. Sometimes people get confused between fortnights and years, and so they'll put down 52 for 52 weeks in a year, but it's actually the 26 fortnights. And they don't understand that you've got to do n times 100 and then t times n for 26 each time. And so the numbers look ridiculous in the calculation. So before we even lunge into this, we'll write it out. We won't do this part, the a equals p times 1 plus r divided by n divided by 1 times 100 to the power of t times n, because we already have that there. It's exactly the same equation or rule as this up here, but we are going to go a is equal to 5,000 times 1 plus 7.3 divided by, and it's going to be 26 fortnights because it's calculated each fortnight, so 26 times 100, so 7.3 divided by 2,600. Again, people see this and they think that is ridiculous. How can 7.3 be divided by 2,600? We've got just a quick reminder that the 26 is for the number of times that it is calculated a year. The 100 is only to convert the percentage, because this is still a percentage up here, to a decimal. All right, so we're trying to convert this percentage to a decimal. I'll make that clear in all the parts of the examples here, but I'll just put that there as well. And then it's going to be calculated 26 times for 3 years. So when you get the 26 times 5, 26 times 3, which means that I've done my little example down here incorrectly. So 26 times 3, will be 78 times. So 5,000 times 1 plus 7.3 divided by 2,600 to the power of 78 is going to give us how much it is going to cost in the fortnight. So let's plug that into the calculators. We'll go 5,000 times 1. Whoops. 1.0028. So 7.3 divided by 2,600 is 0.0028, rounded to the nearest point, or close enough to the nearer number. To the power of 78 equals 6,218.53. So, our three totals are in the accounts after 3 years, but calculated in three different ways. Yearly, straight up compound interest equation. Don't need to make any changes to this. 5,000 times 1.073 to the power of 3 gives us 6,176.88. Bi-yearly, calculated twice a year, we have to change the equation. If it's calculated twice a year, we have to divide our rate by 2, then make it a decimal. And we also have to take into account that the years are being multiplied by 2 as well. So we're doubling the amount of calculations. 5,000, whoops, stop using that, becomes 5,000 times 1.0365 to the power of 6, 6,199.26. And then finally fortnightly, so 26 fortnights in a year, it's calculated 26 times 5,000 times 1 plus 7.3% divided by 2,600, which we know is 0.0028, so it becomes 1.0028 to the power of 78, so 3 times 26 is 78, which gives us $6,218.53. So the question would then remain to be, which one would you prefer to invest in, and which one would you prefer to take a loan out for? So there's a loan of $5,000 being expressed here. Which one of these three totals do you want to be a loan amount? Well, if you're taking out a loan, that means you need to pay this money back. So if it's a loan of $5,000 you've taken out, you'll be paying back these amounts at the end of the 3 years. And obviously you want to pay the lowest back, so you're going to go for yearly. If it's being compounded at anything, you want it compounded yearly, not compounded fortnightly, not compounded monthly or anything like that, because all those situations will change the equation again. I know this has been one of my longer videos, and I know there's a couple blurs and a few mistakes, and I do apologize for that. But hey, hopefully this has helped you understand compound interest even better, particularly when it comes to the aspects of calculating compound interest in the presence of different time frames. And yeah, I look forward to seeing you guys in the next one.